Hello. Can you hear me? Anyone? No, there's like probably one viewer. So if you could tell me if you can hear me, that'd be nice. Um, gonna wait for a couple minutes to see if people want to come in, but yeah. Uh, okay, I'm gonna wait until 9:05. See if any stragglers want to come by. See if anyone wants to come see me. But otherwise, I'll be starting in a moment. Hello. Uh, Just want to make sure my audio is working before I start, but very good. Okay, so currently there's only 2 people, so I'm gonna just wait a little bit before we begin. But yeah, how you doing today? Anything? Okay. Yeah, I think I'm gonna start at exactly 9:05. So if you guys want to wait a little bit, so I'm just gonna like wander a little bit. How you guys doing? You guys have school? Mm. Yeah. Um. Okay, if you guys hear like loud noise in the background, I'm like in my dorm room right now, and like my neighbors are low key kind of loud. They like to sing a lot, so yeah. If you guys hear a lot of background noise when I'm like streaming, it's probably because the people down the hall they really enjoy singing. Hi, Miriam. How you doing? I'm gonna start at 9:05 if that's okay, just to make sure if anyone wants to like come like crawling in here. Are you like a high school student or just making like small talk before we begin? Junior taking AP Physics. That's pretty rad, man. I don't know. I think physics is great. What's that? Yeah, with uh, I'll just begin it with like a brief introduction with who I am. I know I'm pretty new. Were you at the 1 and 2 at the same time? Are they like 2 different classes or one class with 1 and 2? One semester, each a semester, or Yeah, and when I was in high school, I took both physics 1 and 2 my senior year of high school, and then I took like physics CMEC on my own. But after going to college, apparently not a lot of people do that. So you guys are pretty ahead. That's pretty good. Yeah. Ah, oh, dang, that's a lot of physics. So you have two separate classes for physics, right? Dang, that's like double physics. It's a lot of physics out there. I mean, there's a lot of physics out there. There's a lot of content. And I, for all the people who just joined, which is like one or two people, I'm just like hanging out until 9:05, which I guess is right now. So, I mean, I don't want to loiter too long, so I might as well begin. But I'm just doing some like really brief introduction stuff. I'm not gonna put it in presentation mode because I find that to be a little bit annoying. But you guys see my screen clearly? Yeah, no. Okay, I'm gonna just assume that everyone can see my screen. Okay, very good. I mean, okay, so I'm Casey Lee. I like to host practice night. So basically, my vision currently is that I'm just gonna come here and I'm just gonna do a bunch of practice problems and like whatever the topic was on this week. I probably made up with a bunch of different practice problems for us to do together. And if you guys have homework, like if you guys have homework problems that you want to bring to me, I'm also willing to help with those. So yeah, I was thinking that we should do this on Thursday nights because, like I feel like homework is usually due Friday night, and there's usually test Friday night. You can literally ask me anything from physics. I would be more than happy to help any of you out with solving them. Okay, so anyway, I have to like say this, but go follow Think Fiveable on social media. And I'm not paid to say this, but the memes are actually really good. Like they're up to date and they're not like weird memes to like fit in with the kids. For some reason they found a way to make legit memes. So like props to them up there. But really follow our social media. I just want to do like a really brief introduction on who I am. Uh I'm from like a really like normal like public high school or non-magnet. And they're like people from like just like the local neighborhood. We were actually a relatively low income school. So like I'm just like a completely normal person from like a really normal background, but I'm currently a sophomore at Columbia University. So that's just me flexing at all of you, just like saying that, you know, I think that I'm a little bit qualified to teach this lesson, but yeah, I'm studying mechanical engineering right now. I really enjoy physics, and the first time I took physics classes was my senior year of high school, and my entire high school, like my entire childhood, I thought I was going to be a neuroscience major, but taking physics has like completely changed my like entire life plan. So now I'm a mechanical engineer. I might become electrical engineering. We'll see, but yeah, also fun fact, my favorite subject in school is physics. You guys might be surprised. And yes, I did take this course once before, as we were talking about earlier. I took AP Physics 1 in high school. So this is this kind of, I adjusted the slides a little bit, but like this is my first time streaming with you guys. I mean, I did another stream, but like basically no one was there. So I'm gonna ask you guys right now to like tell me in the chat, what do you guys want from this course? Hold on, I was not looking at the chat. Oh, how do I know engineering was a path for me? Uh, I used to work in a lot of labs in high school for neuroscience, and I felt like science was just like a really specified path with a really uncreative way of like achieving things. But yeah, uh, I decided to do engineering over science. But yeah, go ahead. What do you guys want from this course? Just tell me so I know, like going from now to the end of the semester, that what you guys want. Uh, oh, you had a question on the multiple choice. So do you want these Q&As to be primarily like the week's content, or do you want the Q&A to be like your questions to ask me as like a mechanical engineering student like who's taken physics before? Because I can do both. Okay, so I'm just gonna have this Thursday to be like a free Q&A session, but I do have practice problems if we have like nothing else to do. Uh, anyone else want to say anything? Just so I can prepare. I feel like tests are usually on Friday. Okay, honestly, I love physics in general. So, oh yeah, physics C. Oh, physics C is so fun. Because okay, I'll be completely honest with you. I kind of think it's a little stupid to like separate like physics 1, 2 and like the C, mech and E and M because like the ideas derived in physics 1 and 2 kind of necessitate the understanding of calculus. But yes, I've also taken physics C mech, but I self-studied that for like 2 weeks and I didn't get a 5. I will be completely transparent about that. But I did take calculus-based physics last 2 semesters in high school, not high school, college. So I'll most likely be able to help you with that. But like the current curriculum I am in right now, at least what I'm contracted to do is to do physics 1. Uh, getting an A, just pass the AP physics exam. Oh yeah, zoning out during lectures. That doesn't like stop in college. That's what I thought in high school that I would mature. But definitely, I completely understand. Like the way I personally learn is that I like to like do practice problems. I'll be completely honest with you as a college student, I don't remember the last time I paid attention to a lecture. Like just kind of low key. But I feel like just sitting down and doing problems is just like kind of my vision for these streams is has been the most helpful in my opinion for these streams. So like I was thinking about a way to like approach these streams in the future. So if you guys like leave a topic for me like inside the chat like the week before, I can prepare some material for you the following week that I can help you like study for a test. So let's say you know in a week from now that I'm going to have like let's say a rotational motion test. And on that Thursday, I can say like, I have some material and some tips that I've been using for like my own approaches in like rotational mechanics. Do you think that would be helpful to you guys, or do you think you guys just want to come in and just roll in Thursday and not know what's gonna happen next? Oh, yo, I feel freakishly smart. Uh, yeah, yeah. Self studying. I honestly, I don't feel like streaming. Okay, being completely transparent, I feel like these streams are really good for self studying material, but I feel like the the curriculum we set up will definitely not match up to like high school curriculum just because of like randomness and how your like semester set up. So I was thinking that like, yeah, this is my streams are kind of more freeform. And just as a heads up, so you guys know, I'm gonna stream every single Thursday at 9 p.m. So yeah, any more questions? Any more like requests? Anything else you want out of like me or this course? That I can also talk to the lead teacher to like adjust the curriculum as a whole if you guys really want to. Like any last things before we start? We good? We good? Thumbs up in the chat. Anything? Okay, I'm just head straight in. So like I think first, it seems like you guys are interested in like giving me problems that you've seen in class. So I know that a lot of you guys aren't in the same class because you guys are on the live stream, but like seeing what is on like other people's tests can help you understand what's going to be on your test as well. So if you guys have any questions from your physics classes, I go ahead and ask them right now. I'm gonna spend the first half of my stream doing those, and then the second half probably doing the practice problems that they have set up. So you guys, anyone have questions? I have practice materials set up. So I mentioned, okay, also for today, could you please go over some practice problems? Oh, kinematics and acceleration. I love acceleration. Okay, so when they say kinematics, is that like just velocity, acceleration, motion? Okay, that is actually, we're covering that content next week, in fact. So do you have like a test that's coming up soon that like today is like in particular? Okay, okay. Would everyone else be interested in learning about acceleration, kinematics, and motion? Anyone else? Or anyone else have an objection right now? Uh, being tough. Ah, dang, next Monday? At least you have the weekend. A piano is being lowered from a 10-foot building. The rope at 30 meters. The people below realize that the rope snapped when it is 14 meters away. What does this mean? Is this a question? I'm in physics and we had this problem. So what are we looking for in this problem, Miriam? How long do they have to get away? Okay, okay. This is good because this is also a kinematics problem. So this will help everyone who's in the chat right now. So let me open up. Okay, what I like to do is that I like to use MS Paint canvases because I am technologically inept of using anything else. So hold on, let me change my stream. Okay, hold on. Ah, dang, I'm like technologically inept. Okay, hold on. Let me just a moment, guys. Application MS Paint. Okay, you guys see what I'm seeing? You guys see an MS Paint canvas. Okay, so this is how we're going to do things. I'm just going to use this as a whiteboard and you guys are going to, I have the chat open so I can see any comments. And I'll be completely honest with you, I'm just a student and like even like my high school teachers screw up sometimes, even my like college professors. So tell me when you see I'm doing like something really stupid, okay? Okay, so we had this problem. A piano is being lowered from a 10-foot building. So of course you guys always want to start with a diagram. So this is 10 feet. And we have, okay, I'm assuming that this is being lowered at the height of 10 feet at 30 meters. Okay, so this is good. So this week's topic for physics is that we want to do unit conversions. And it looks like we have a 10-foot building and it snaps at 30 meters. Wait, 30 meters. 30 meters is longer than 10 feet. At 30, okay, but, oh, okay. You know what? I don't care about the piano. So let's talk about how long it takes an object to fall 14 meters. Okay, so I'm sorry, me. I don't quite understand the beginning problem, but I think I know how to solve what you're looking for. So there's a lot of kinematics equations. Let me pull up you guys know the equation sheet, right? So there's a bunch of kinematics equations that were given on the AP test. So let me just Google like the kinematics equations, copy, paste. Okay, you guys seen these before, right? So these are the equations that you're given to solve all of these problems. And you're supposed to manipulate all of these equations to basically solve any kinematics problem you want. So right now we have an object that is, oh shoot. Okay, you got an object that is falling, right? And we know that acceleration is about 9.81 meters per second squared on Earth, at least at like sea level, correct? So we know acceleration, but we want time, right? Okay, and like just another little tricky thing that we know is that velocity initial starts at 0 because when you drop something, the beginning velocity is at 0, but it increases once you get closer to the ground, right? So what we're going to try to do is find a kinematics equation that has these three variables. Well, it has these three variables and solves for t, right? So what do you guys, I guess I need to be more interactive. So particularly Miriam, because you're the one who's solving this. Which equation do you think? Also we know delta x, which is 14 meters. That's probably important. But which kinematics equation do you think you would use? 1, 2, 3, or 4? So throw that in the chat. What do you guys think? Anyone have any guesses which kinematics equation to use? 1? Anyone else? Anyone else? Third equation? Anyone? I'll take one last response. Okay, so what I would personally use is number 3. So anyone who solved that, great response. But the reason why you shouldn't use number 1 is because, okay, so we know velocity initial, right? Yeah, we know this number, but we do not know this number. And we also do not know this number. Although we do know this number, we have 2 unknowns and we cannot use that equation. So clearly, like, once you put in all of the variables, you're going to have 2 unknowns and you can't solve an equation with 2 unknowns. Whereas this one, delta x is v initial t plus 1/2 at squared. That has like literally everything we have. We have delta x, 14 meters, v initial, which is 0, t. Well, anything times t is 0. But we have the unknown, which is t squared. And that in turn, like we can just throw all of these variables in and it will solve. And like something that you might notice that none of these equations have mass in it. So whether or not you're dropping a piano, whether or not you're dropping a feather, with 0 air resistance, it will take the exact same amount of time to fall, right? Would you guys be interested in seeing a derivation for this equation? Or is that like just me being a nerd? Like it could be useful later, but it's like a way I logically see it. Like just be honest with what would be useful, like of your time right now. Actually, yes? Okay. So, okay. The way that I've interpreted this equation is that, you know how distance is equal to velocity times time, right? So when we have this equation right here, what I try to, I guess, interpret this as is like velocity times time, velocity initial times time is like the beginning point, right? So you have, let's say you're like a runner. I don't think I'm explaining this really well. Let me take a few steps back. Okay, I think that the best way, most important thing to explain right now is this 1/2 at squared value, right? Because let's just currently assume that v initial is always 0, right? And you want to find the delta x with some certain acceleration, with some certain amount of time, right? So assuming that there's constant acceleration, right? Let's say that this is delta x and this is t. Oh, no, that should be delta x. That should be delta v. V, not delta, just v. Okay. So this would be the graph of a constant acceleration. And when you're in physics 1, you're not going to get any sort of variable acceleration. So you're not going to have like this whack-ass acceleration that's going to go crazy. You don't need to worry about it. So in our current concerns of this kinematics equation, we can see it as a straight line, right? So we know that at the beginning, we're 0 velocity. At the end, we're at a certain velocity, right? So what I like to think of this as is that, you know, what would probably be the average velocity? Probably somewhere in the middle, right? Like probably the average velocity, when you take all of the velocities, the average, you can take that average velocity and multiply it by the entire amount of time. Does that make any sense to you guys? Or yeah, because like, you know how like a 0 velocity is going to be balanced out by like 10 meters per second, and there's going to be a 2 meters per second. Like it all just cancels out and you could take one average acceleration, right? So, okay, that makes sense. So we know that the final velocity, so v final is going to be equal to acceleration times time, right? So like if you accelerate, if you increase your velocity by 9 meters per second, after 1 second, you will be at 9 meters per second, starting at v initial equal to 0. That makes sense, correct? So we can all agree that v final is 8 acceleration times time, right? Okay, so we know that this is v final. So this value is at. And you know what this looks like? This looks like a right triangle, right? And you know what we can do is that we can just do acceleration times time, base times height, squared times 1/2. And that is how you get this specific value. Like at least, and like this is a derivation I made on my own in high school. So like this isn't like in the curriculum, but this is kind of how I understand acceleration, at least this specific kinematics equation. Does that make sense, guys? I just don't want to lose anyone too quickly. Okay. But okay, so this v initial times time. I know that my canvas is super messy, but basically what that is saying is that, oh, that was really ugly. Okay. But that is basically saying that you have initial velocity that is non-zero, right? So you have this 1/2 at squared value that covers this area, right? So when you say that there's an initial velocity times time, this is v initial and this is time. And this is this area. And the area under the curve, this is also going back to how like all physics is related to calculus. The area under the curve is the displacement. So once you add all of the components together, you get delta x. So that is how you derive that equation. That's pretty cool, right? You guys have any other questions? Or do you have any clarifications you want me to make about this equation? I mean, like if you understand that, you also understand how to derive this equation as well, and also this equation. I don't know how to derive this equation. I haven't thought about it that deeply, but yeah. Anyone have any questions? Any clarifications before we continue? Anyone? Okay. Do you guys want me to continue covering kinematics, or do you guys want me to cover like percent error? Anyone? We can cover falling objects. If no one's gonna say anything, I'm just gonna do like percent error. Yeah, oh yeah, sorry. You just plug and chug. I just did not have the effort. If you want, I can plug and chug right now. Like I do not have a real calculator, and I don't feel like it'd be professional to take out my phone. But yeah, you just plug and chug. For the other 16 meters, it drops. Oh yeah, okay. But okay, that means that there was an initial acceleration. So v initial is not 0. Yeah, so okay. Do you want me to do you understand what I mean though? So what you need to do with that problem is that you need to find the amount of time it takes to drop that far. Okay. What you can do is, so you have the exact same variables, right? You have this part of the equation that is exactly the same, except you don't know t, right? And you can solve for delta x for first 16 meters. And then what is the total amount of distance you drop? The total amount of distance you drop is 30 meters, right? And then you can solve it for 30 meters, and then you just subtract the two. Yeah. Yeah. That sounds about right, Miriam. Yeah, exactly. Does that make sense, Milan? Is that how you pronounce your name? I hope I'm saying it right. But do you understand why that works? Like you find the total amount of time, and then you take the amount of time it takes to drop 60 meters. Okay. Okay, anything else that needs to be clarified? I was talking with a friend of mine here at school, and he has this other really strange way of like contemplating. What is it? Oh, yes. There is a very, very different way of approaching this problem that does not involve kinematics, but involves kinetic energy. Have you guys covered kinetic energy before? Would you be interested in that approach, or would you much rather like learn about percent error? Anyone? Ah, I see, I see. But what would you guys be interested in doing right now? Kinematics unit? Okay, okay. Let me be honest with my personal approach to kinematics in high school, at least. Like, I've never used the equation sheet for these kinematics equations because, like, by conceptually understanding like velocity and acceleration and time, if you understand it at a really mathematical sense, I really don't think you need the equation sheet for the kinematics equations, at least. It's a very different situation in physics too. Sorry about that. But yeah, I don't know how to fix that, man. Sorry. Uh, but yeah, I feel like if you understand the equations, you don't need the equation sheet at all. Yeah. So I'm gonna assume that I don't know. Okay, you guys just give me the judgment right now. Do you guys want to learn the weird kinetic energy method, or do you guys want to do like percent error, dimensional analysis, or do you guys want to do more mechanics, kinematics? Anything? Anything? Interested in what though? Okay, you know, this explanation of this like really weird way my friend does these like drop questions, I think is like enough to justify me doing it, okay? So, okay. So do you guys know about potential energy? Okay, like gravitational potential energy is equal to mass times gravity times height. So that is like, yeah, and kinetic energy is equal to 1/2 mass velocity squared, right? Okay, so what my friend does with these drop questions, so there's gonna be hundreds of drop questions in like physics AP. It's gonna be an insane amount of drop questions. Like you need to get really good at these drop questions, these kinematic questions, these like launch questions, all types of kinematics, and particularly these drop questions. But the shortcut to doing these is that what you do is that, especially if you're just dropping it with an initial velocity of 0. So initial condition velocity is 0. What you do, you find the amount of height it drops and throw it into this equation, right? Because that is the amount of potential energy it has. So let's calculate the potential energy it has at this position. So I don't know. I don't think you need to like put in like random numbers. But let's say that this is like 8 meters, and this is 1 pound, and gravity is equal to 9.81, right? And let's say you want to know the final velocity. What you do is you just plug and chug. You put in the mass. We don't use pounds here. We use kilograms. Okay, 1 kilogram. 1 kilogram times 9.81 times height. Okay, that is a potential energy. And since like you cannot create or destroy energy, the final energy is going to be equivalent 1/2 mv squared, right? But because mass doesn't matter, you can cross that out. And what you do is just you do gravity times height is equal to 1/2 v squared. And that's pretty cool. That's like a shortcut. Incredible, right? I didn't know this in high school. So basically the final derived equation. Mass times, not mass. Gravity times height is equal to 1/2 v squared. Yeah, how do you find final velocity? But yeah, can you use it to find time? You can just throw into another kinematics equation to find times. You can throw into 1/2 at squared because velocity initial is 0, right? No. You can just do no. You can use the first. I don't know what I'm talking about. So you just do v equals a times t. So you just do 9. If you want time, you just do v divided by t, basically, and you have the entire thing. You have everything you possibly need. But yeah, it's pretty cool. Anything else? I'm gonna start working on the preset. Don't save, it's pretty ugly. Okay, I'm gonna just work on the preset stuff I have until you guys have questions, if that is okay. So if you guys have a question in the middle of my stream that you thought of, I'll finish my problem and then I will continue to solve your problems. Okay, so this week's lessons, I'm not sure if you were on the last stream, but the last stream, I think the teacher taught about dimensional analysis and what was it? I have it somewhere down here. Error analysis? Yeah, pretty cool stuff. So right now, I start with dimensional analysis. And I know you guys might think dimensional analysis is a chemistry thing. It's absolutely not. It is an everything thing. Like you need dimensional analysis for everything. Like just being alive, dimensional analysis is very useful. And like even if there's a very, very simple conversion, I highly recommend you do dimensional analysis because it ensures that you make 0 mistakes. Like I remember I was sitting down on the SAT and I thought this was like a really simple conversion and I was about to screw it up, but I did dimensional analysis. I realized I was wrong. So I'm just going to do some really, really basic dimensional analysis problems right now. So let's start with this one. Let's start with like 15,968 grams to kilograms. You can do this in your head, but let us do it the long way. Grams. Okay. And then, you know what? There's 1,000 grams in 1 kilogram. And I'm not sure if you guys already took dimensional analysis. I feel like it's a really big chemistry thing, which kind of makes sense. But what you want to do is just cross out all of these values. And you want the final value to be what you're trying to convert to. So this one, you just do 15,968 divided by 1,000, 15.968 kg. Yeah? Okay, 1 year to seconds. So 1 year, and there's 365. Oh no! You see, I was about to mess up there because I was being stupid. 1 year has 365 days, and then 1 day is 24 hours, and 1 hour has 60 minutes, and 1 minute has 60 seconds, yeah? So this crosses out, this crosses out, this crosses out, this crosses out. And I don't think you guys really care about what this multiplies out to. But once you multiply it out, it'll come out with the amount of seconds you have. I hope that makes sense with you guys. Because I do not have a calculator right now. Okay, this one's pretty tricky. So this one, when I was writing problems, I was a little bit confused because it's like a squared value, and I've never really done dimensional analysis with a squared value. So I looked up how to do this. So this is what they told me. Also, if you ever use like feet per minute squared for acceleration. That is absolutely disgusting. But let's do this. 9.181 meters per second squared times, okay. Oh, we were just doing kinematics. You just missed it. Sorry about that, man. We're currently doing dimensional analysis, which is also extremely useful, but yeah. If you want, you can drop a question and we can do it at the end. Oh, sorry about that. I should probably say that in the chat. Is it working for the rest of you, or? Okay. Let me type this out to make sure you can see. And I will. Okay. Sorry about that, Taylor. You can't hear me right now, but yeah, no problem, man. This thumb is for you, even though you cannot hear me. Okay. So right now, we have the option to convert first to minutes or first to seconds. And because I currently know the conversion from seconds to minutes, I might as well just do seconds first. So 1 minute squared is equal to 3,600 seconds squared. And the reason why we do 3,600 is because the value is squared, right? Which makes a lot of sense. If you're converting a squared value, of course you square the value itself. And then, okay, so then since these already cancel out and we already have the minute squared value, we need to convert it to feet. I don't know how many meter in feet. I'm gonna Google this on my computer right now. But 9 point, what was it? Meters to feet. Okay, and if you guys didn't know, it doesn't matter whether or not you're converting meters to feet or feet to meters, the proportion is pretty much the same. So it's like, it said 1 meter equal to 3.28 feet. Okay, so, okay, let's switch. Let's do feet to meters as well, so I can like just prove a point. I'm pretty sure you guys already know, but so 1 foot is equal to 0.3048 meters, right? And you guys know what? This is just like the reciprocal of the other. So the way they got 0.3048 is just by taking the reciprocal of 3.28. So it doesn't really matter if you use this conversion or this conversion. It doesn't matter because as long as you cancel out the units, it should still all like work out because it's just a proportion, right? So I might as well just use 1 meter for 3.28 feet because I feel like it's cleaner. 1 meter to 3.28 feet. And that should get you the value. Do you guys actually care about the solutions? Like, do you guys care if I solve it? Because I don't want to put in the calculator. Yeah. So I'm a not put that in the calculator. Okay. Yeah. That doesn't sound very interesting to do. Okay. Right now we're going to do error analysis. So this is a live stream, so I might as well do this live. Let's talk about how many people are on this stream right now. So when I made this set of problems, I predicted that there will be exactly 2 people on this stream. Because I was like, I didn't think, oh, it closed. But hold on. I thought there would be 2 people on my stream, and it looks like there are 6 people on my stream. I'm doing great, guys. It's not a lot, but like doing amazing. So the way you do error analysis is that like you do reality minus, okay, I'm just making up the variable names. I forgot what they were exactly called. Reality versus expectation divided by expectation. So it's kind of like the percent amount you were off, right? And it doesn't really matter if you do reality minus expectation or expectation minus reality, because this is absolute value. So it's going to turn out to be the same. So there are currently 6 people watching my stream, and I expected 2 people divided by 2. I am 200% off. And I'm very happy about that. Okay. And okay. I think this one requires calculator work. I don't know why I wrote that question. But yeah, I'm gonna skip number 2 for now. Let's do number 3. Okay, gut answers. So there's a lot of times where you think that like your first impulse on the solution of a problem is correct, but in fact it is not. So I wrote these questions to do that. So if I thought 2 people would show up to my birthday party, but only 1 did, what would be my percent error? So my expectation for part A, my expectation would be 2. My reality is 1 divided by 2. That is equal to 50% error. Over center of mass, yes, we can do that. I'll do that right after this. It's going to be real quick. Okay, what if I thought 1 person would show up to my birthday, but in fact 2 people did? What would be my percent error? So this is like the exact same amount of like numbers I'm using. I'm using only 1 and 2, right? But the only thing I'm doing is that I'm switching their positions. So I'm switching like whether or not that was a guess or whether or not that was the reality, right? And just by doing that, 1 minus 2 divided by 1 absolute value, that is a 100% error. That is a completely different solution. So yeah, that is different from the reality of things. Okay, let's do center of mass. Okay. So it kind of depends on what center of mass. Center of mass can get really complicated when you get into calculus-based physics. And that requires taking an integral, so you'll probably have like a density function. So probably like density is equal to like distance times like some constant. But I don't know what center of mass you're talking about. So what kind of center of mass do you want? Like the calculus one, or like I think right now because like I want everyone on the same page, I'm just gonna do like a really physics 1 approach to center of mass, right? So how am I gonna go through this? So let's say, okay, this will be useful to everyone eventually. Okay, and this is how I like kind of thought of how to do this. Like most of the okay, I'll go do that problem after, but most of the way that I've been approaching physics, and at least in my high school career and in my college career, is that like I try to derive my own solutions, and if they work, I would prefer to use them rather than the equation sheet because I understand how it works. And like if I understand how it works, then definitely I'm not gonna like mess something up with like the variables or something. So let's take a problem. I'm not sure if they'll teach you this in school because this is kind of like my method of doing things. So this is a rod and this is a rod. Okay, Milan, tell me if like this is something you're seeing on your end, because Like what I've been learning for center of mass might not be the same for what you're learning of center of mass. So when you're in physics 1, it's all algebra based, right? It's beautiful. Everything works out. But once you get into calculus, you're going to be like, okay, like this, the beginning of the rod is more dense. And then once you get further into the rod, it becomes less dense and it has less mass. And it's annoying. It's really annoying once you get to those situations. But right now, it's very beautiful. And we can assume that it has constant density. Accelerate. Okay. That you don't need to like worry about like center of mass because like you just what you do is you just treat, particularly in physics 1, when we have kinematics equations, we treat them as point masses. So they can say that like this is like 500 miles wide or something. It doesn't matter because when you talk about like a singular object accelerating, like you can treat it as a single particle. Right? So 2 objects were moving and we needed to find the acceleration of the center of mass. Okay, but when you have 2 objects, if they're accelerating at the same rate? Oh, they're accelerating at different rates. That is what you're saying. Okay, let me think about this. Okay. So the center of mass. Okay, the way you calculate center of mass is that you do mass times the x displacement. So this is a coordinate system, right? You got all these lines. Mass times x. Okay, mass 1 times x. Okay, honestly, I don't know how I'm going to solve it right now, but let's try to derive the solution, right? So you got mass 1 times x plus mass 2 times x. So when you have acceleration, you have 1/2 at squared, right? And that is equal to velocity. And then when we want velocity, no, that's when you get distance, delta x, right? So what I would suspect you should do, mass 1 times x. So what you do is you take that value, replace it for x, right? Delta x, assuming that x is 0, right? So you do mass 1 times 1/2 at squared, but then that would just result in the location of the center of mass. It's equal to, wait, hold on. I forgot something really essential about the center of mass equation. You add mass 1 plus mass 2. Yes, that is the actual equation. And then let me think. So you have that, and you have x. Okay. But this is kind of cheating. But you can find like, you can kind of average the accelerations, right? So, okay, this is how I conceptually understand it, right? So let's imagine you have like 4 particles, right? And you have like 2 particles, right? And these are all like 1 kilogram particles. Okay, I think this is right. Okay, let's assume they're all 1 kilogram. I don't need to label all of them. And let's say that all of these are accelerating this way. And these 2 are accelerating this way. So wouldn't it make sense to just average all of these accelerations? And that would be the acceleration of the center of mass, right? And then because, that should work out. I actually do not know how to approach this problem. I've never seen it before. Because it's possible that like they're accelerating at like complete opposite directions and the acceleration will ultimately be 0. But once you average the accelerations, yeah, even if it were like positive and negative acceleration, it should still cancel out. So you know how like this equation is derived with the center of mass, where like mass 1 times x plus mass 2 times x is divided by mass 1 plus mass 2, which is like the same concept as like all of these little masses, just like averaging all of them into their position. I think you could do the same thing with like mass times acceleration, mass 1 plus mass 2 in the denominator. You'll probably get the acceleration of the center of mass. Like I think that's like the most likely derived equation. Like is that like somewhere like close to like what you would probably think? What do you guys think? What is your input on this? Yeah, I think that is right. But yeah, I'm not gonna say it is right, but that would be my suspicion, and that is how I would solve it personally. But yeah, sorry about not fully like being able to help Milan, but yeah, good luck with that test. Yeah, but yeah, that's just a derivation of. It should work out the same way. Yeah. Oh yeah, it should work out because the units cross out and it comes out to be the correct units. Yeah. Okay. Don't quote me on that, but and if you don't trust me 100%, make sure you check with other people before you trust me. Okay, so Taylor, you had one problem. Taylor, can you hear me at all? Oh, okay. Okay, that's very good. So we were covering this earlier. Okay, so you see these, just a quick overview. I might just talk about this for like a solid minute. But you see these kinematics equations? Okay, sometimes you have, okay, let's say you use this equation when you have velocity and acceleration. So you can solve for time. Or if you have acceleration and time and you want to solve for velocity, or you have velocity and time, but you want to solve for acceleration. What you want to do is find the equation that only has one unknown. But as I was talking about earlier, I feel like you should learn how to derive the equations yourselves. So you don't really need to think about like which equation to use like in that way. Because I feel like that's a really surface level way of understanding kinematics equations. If you see and understand how they are derived, you will know which situations to use them in. If you understand what I mean. Okay, so this is gonna be the last problem I'm gonna do tonight. Okay. One problem I'm working on: supersonic jet flying at 200 meters per second at a rate of 20 seconds. Okay, so let's do this. Okay, we got airplane. Yeah, this is your official AP Physics artwork. Supersonic jet flying at 200 meters per second. Okay, we got this. It's accelerated uniformly. Okay. I already know which equation to use. It's the equation. I know you weren't here, Taylor, but it was that one equation I was deriving earlier with 1/2 AT squared. And that's because I kind of conceptually understand where this is going. It's accelerated uniformly at a rate of 23. Acceleration is 23.1 meters per second squared for 20 seconds. You see, exactly. It's going to ask for displacement now. Yeah. Physicist Ernst Mach studied the effects. Wait. Is this a separate problem? Okay. Studied the effects of motion faster than sound. The ratio of the speed to that number is called. It's Mach number. Mach 1.00. Yeah, blah, blah. It's about 3, blah, blah, blah. It's a max speed of our jet. Oh, it's looking for final velocity. Oh, that's incredibly simple. Okay. This is not even that kinematic equation. I was getting a little bit ahead of myself, but this is just V initial plus V times T, right? Is equal to acceleration times T is equal to final velocity. And that is an extremely simple equation to derive because acceleration times time is just velocity. So basically you're just finding the final velocity of this situation. So what you do is currently it's at 200 meters per second, but after it accelerates 23.1 meters per second squared for 20 seconds. And I want you guys to notice that once I multiply 23.1 meters per second squared by the time, 20 seconds, it crosses these two out. So it's going to be meters per second plus meters per second. And whenever you're doing these types of equations, you always want the units to cancel out. That means you're doing something right. If the units do not cancel out, if you're trying to find kilograms and somehow you get like meters, you're doing something wrong. And when you're doing work for these problems, you always want to check, am I getting the correct units? And I'm looking for velocity right now, and it is velocity. So it's going to be, I'm not going to plug these into the calculator. I'll bring a calculator next time. And I also don't want to like do your homework for you. I want you to conceptually understand what's happening. But it's just going to be 23.1 meters per second times 20. Yeah, that is the solution. You'll get velocity, right? And then what you do is you take that velocity, and like this is just according to the definition. This is in meters per second. So what you just do is do that number divided by 331. Yeah, just that number divided by 331. That's gonna be it. Okay, I think we're out of time now. So just like as a brief, like, oh, I should probably, I'll do that later. But okay, hold on, let me close this video. But yeah, just as a quick overview of like things that happened and what to continue for next time. If you guys have any questions for me next week, just like leave them in the chat. I can have material prepared for you. I can like think of like different ways to derive solutions because I love deriving solutions. That's like my favorite part of physics. So if you have like a test next Friday, drop it in the chat. If you have like, I should ask my Fiveable people if there's a way for like a messaging platform for you guys so you guys can message me during the week. I'm so glad I can be helpful because like, you know, I'm just a student and like I know what it's like to like be a student and like not understand. So these are approaches that I've been using personally because like teaching, I don't know, just like being taught is kind of hard. But if you guys have like a test next Friday, drop the topic of that test and I will be going over it next Thursday. I will have material and I'll have derivations ready for you. If you want anything special next week, if you would like more of the Q&A or if you would like more of the practice problems, next week is kinematics. You guys seem to be a fan of that, probably because your school's doing kinematics right now, but you know, whatever you guys want. I'm like your resource. Anything? Yeah. Okay. Yeah, I'll just, I don't know. I hope this stream was helpful. I hope that like I can teach you some tips and tricks. Okay. So yeah, I'm doing this every single Thursday at 9 p.m. Once again, I'll be available. I hope more people come. So if you have friends who have like questions, feel free to drop by. Okay. So I don't know what time it is for you guys, but it's already 10 p.m. So for me, I'm gonna sign out. Okay. I actually do not know how to like turn this off. Okay, I see the turn off button. Okay, bye guys.